I'm doing good. Thank you. How are you?
Not bad, thank you. I see as in all video on YouTube, you are in the hat. You're wearing
Oh,
hat every
yeah,
time.
yeah, yeah, yeah.
Is it so
Hat
cold in
and
Norway?
I've been. Yeah, it is. And not only that, I have curly hair, so I tend to put some hat because otherwise it would be just like boom.
Oh, every girl dream about curly hair. Okay, Devlin, thank you very much for this nice small
hmm
talk. The stage is yours. I'll come back in 25 minutes with the questions.
hmm Sure. Okay, so let's start. By the way, again, I'm Devlin Duldulao. I'm a senior consultant here in Norway, and I'm here to talk about PASETO, or platform-agnostic security tokens. Uh, okay, so just a recap of JWT. We know JSON Web Tokens are an open source industry standard RFC 7519 method for representing claims securely between two parties, right? And here's the JWT sample. You have the subject, right? And IAT as issued at time. This is just uh, a basic of JWT, just to have a recap here. Of course. So next, oops, slides here. Delay. So JWT is used today for securely exchange information between two servers and for single page application authentication and authorized operations across servers. And we have acronyms for this. Let's go for some acronyms here in JSON world. So we have here the Jose, I don't know how to pronounce that. It is a framework intended to provide a method to securely transfer claims between parties. And here we have this JWT, which is representing claims in compact in URL safe means. And JWE, yeah, we also have JWE, which encrypts content. JWS secures content with digital signatures. And we also have JWK, represents keys used for signing and encryption. And lastly, JWA, this is actually a cryptographic algorithm and identifiers used with all of the above. And some supported algorithms here. We have HMAC plus SHA-256, which is asymmetric, RSA plus SHA-256, which is asymmetric, and we also have ES-256, it's an asymmetric key cryptography, algorithmic elliptical curve digital, etc., and PS-256, which is RSA also, using SHA-256 and MGF1. So these are just supported algorithms of the Jose. And just a quick look back on symmetric encryption and asymmetric encryption as well. In symmetric, one key session, and in asymmetric encryption, we have the private and public, which is two keys, right? And so signing versus encryption. Encryption, unreadable, unreadable data to unauthorized parties. That's how we use it. And then also for confidentiality. And for the signing, we need it for data integrity and non-repudiation, message authentication, and most of all, integrity. And there are also multiple ways of signing. So here we have with the secret using HMAC, and another one with a private key using RSA, just asymmetric. So yeah, these are the ways of signing. And another one here, remember, multiple systems can issue tokens, and a token can be used by multiple systems, and all of these systems can use different libraries. So we're done here with the recap. So let's go to the vulnerabilities and exploitation in JWT. Here are just samples, or most common, and you can also find a lot of these vulnerabilities. So one would be not checking the signature. So some JWT libraries methods here are decode and verify. So we all know here's the decode is just gonna decode the token without verification or verifying it. Um, yeah, and getting the claims or the payloads of the token, but not really checking if this comes from reliable source. So exploitation here: get a token, decode and tamper with payload, then send the token. Now you can use it. So that's one of exploitation here. And another exploitation that you can see in JWT is the none algorithm. None, so meaning used to be supported actually by default in few libraries. Basically, none don't sign the token. So that's the meaning of none. And exploitation here. How to do it? Get a token, decode the header, and change the algorithm none or none. You see, and then decode and tamper with the payload and keep or remove the signature. The second, another exploitation here in JWT, we have algorithm confusion. For instance, the token has been signed been signed using HMAC instead of RSA. If you tell the receiver it's an HMAC and it verifies it with a public key, thinking it's RSA. Exploitation here in algorithm confusion, you just get a token signed with RSA, you only have access to public key, and then decode the header and change the algorithm from RSA to HMAC. Here's our sample. And then tamper with the payload, just replace it, whatever you want, and then sign the token with the public RSA key. Another vulnerability is the KID parameter. So KID is an optional header claim which holds a key identifier, particularly useful when you have multiple keys to sign the tokens and you need to look up the right one to verify the signature. This is done prior to the verification of the signature. And exploitation here. Yeah, here, get a signed token containing KID parameter, decode the header and change the KID with the SQL injection payload, tamper again with the payload, and then sign the token using the return value from the SQL injection. Another vulnerability. So we have here weak keys. So an example, JWT sign with the HS256 here and secret. So remember RFC 758 standard states that a key of the same size has the hash output. For instance, you have 256 bits for HS256 or larger, must be used with this algorithm. So you can easily extract the secret key here. Because why? This only 4 characters here. It's like SN1F. You can easily do this. I'll let you show how. Exploitation here. Get the JWT cracker. You can download this. You can find it in the internet. Just Google for JWT cracker, and then run this JWT crack, and then pass the token, and you can now extract the secret here. For example, here it's SN1F. It This only takes, I think, 10 seconds, depending on your computer. So the moral lesson here is as much as possible, use more than 16 characters or 12 characters of to create key or for your keys, because the longer the characters of your key, the more protected your token will be. And there's more actually. Invalid curve attacks, and library CVE. You can also find this online. There's a lot, and etc. So these are the expectations that you can find in JWT. So developers need, we need easy to use tools that don't open the door to a ton of attacks, right? And there are a lot of ways for JWTs to go wrong. Bake in the HOSE or the JOSE standards that I showed you earlier. The HOSE, the advocate response to this criticism of different exploitation, is use specific library. So that's their response. The problem here is this shifts the blame into the library developers and the library users. And we have these industry anti-patterns here. Example, standard designers. Let's give users a lot of choices. So that's an anti-pattern. And the advocates, they'll blame the implementation rather than the standard. And the security experts would say declare a standard harmful, and then they provide no alternative. And then we end up, we developers, we end up rolling our own crypto, which is not the recommended way. So can you really blame us developers? And here's PASETO. So what is PASETO? Platform-agnostic security tokens. So PASETO is, this is what you can find in the PASETO website. PASETO is everything you love about Jose or Jose. The JWT, the WE, the JWS, without any of the many design deficits that plague the Jose standards. So let's go to PASETO format. So here's PASETO format. We have the payload, we have the purpose, the version, and there's the optional footer there. And you can see also the color here. The version would be this V2, and the purpose will be the local here. You can see it also the explanation later. And the payload, which is this token here, and then the footer. So what is the version? So version tells you what version of PASETO is being used with token. If version 3 comes out a year from now, then users would only be allowed to use version 2 or version 3, but no longer version 1. So compatibility mode, you can see there, and then the recommended one is the V2. So what about the purpose? So local referred to as symmetric or shared key PASETOs, because that is the type of cryptography that they use. Always encrypted, so that's local. An attacker that was able to get a hold of the token will not be able to see the data inside unless he has a key. The public, on the other hand, both PASETOs are always signed, but public is not encrypted. So what's inside the PASETO payload? Just like a JWT here. You have the ID, email, permission, those regular claims. You can also have the sub, the AUD, the EXP, which is expiration, the default, those default NBF, not before, the issue that, the KID also, you can also use it here. So those are the default in JWT also. default key that you can find in, or you can use in PASETO payload. So here it is, the ISS, which is the user who created the token, XP the expiration, when does the token expire, and samples here again, the IAT the issued at, when was the token created. So that's the payload. And what about the optional footer? So some people wants to do key rotation. So they would want an encrypted part of local token. They get stored like a key identifier that references a specific public key or specific secret key. So here's some PASETO implementations. I got this, I think, last year. I'm not sure if this the case is. They're still on progress. Some of the libraries here. So we have here the for Go, which from supported from version 1 to version 2 of the local and public. In .NET, the only not supported is the version 1 local, and there's also for Node.js, which from version 1 local to version 2 public are supported. In PHP also, everything supported, and Rust as well. So Swift, as you can see, you can now you use PASETO in any programming language and framework. So we have here JWT versus PASETO. Just a really quick here. So JSON Web Tokens has a lot of options, including often unauthenticated options. And PASETO, on the other hand, you have two options, version and purpose. Everything is authenticated. Local tokens are always encrypted so that you don't accidentally leak sensitive information for a local system. And then is the creator of PASETO. Um, he mentioned some important things in PASETO, and here they are. Basically, you should have an opinionated interface. That's right, opinionated, because we're not, most of the time, developers are not expert in security. That's not our forte. Usually do mobile and web application and web development, or sometimes desktop development, right? So yeah, you should have an opinionated interface. So we have a guidance, and then the encrypt here. This should be your API for any encryption library, and you have your message, your key, and an optional data to including the authentication tag. Decryption should be exactly the same. You should have hard-coded version protocols, which means that, like PASETO, you have version 1 and version 2. And what else? Mentioned you don't have version 1 ECB mode and version 1 counter mode. You just have one version, and that's it. And always logically separate symmetric from asymmetric cryptography. Okay, a quick demo of PASETO here. We still have time. Show taskbar. So here's a Java code, and here's I'm using the PASETO library for Java. And basically, you have here sample of methods that you can use. You have create token, parse token, get claims, get audience, right? Parse token with requirements, I'm just logging it here. And you also have these, yeah, the claims. Yeah, basically it. And then here's the result of it. We have here the parse token. We have the version 2 local, and then the payload here, all the way here. And the claims, you can see here, I'm just printing out the claims. AUD, Devlin Duldulao, expiration here, and then audience, custom claim. Yeah. So this is just an example of PASETO. So uh, for more information, yeah, you can go here to Scott Brady, 91.com, OpenID, and npm JS, JS for other resources. You know how to do some best practice in security. And yeah, so that's it. That's a quick introduction of PASETO, just a replacement or alternative to JWT if you want to try, if you want to read. So yeah, I hope you learned something here. Thank you.
Thank you very much, Devlin. Thank you.